the core diameter of 4 millimeter and the core diameter of 5 millimeter even, and which has only 3.3 millimeter table. So no need to worry about to make bone defects about implants. Just after making punch, it's only 3 millimeter in diameter. You can take out the soft tissues to recognize how thick the soft tissue is. Usually, in this area, we have a 3 millimeter or 4 millimeter thickness of soft tissue. And then we can calculate the exact depth of the drilling. And then through this hole, 3 millimeter diameters, we can use trephine again to take some bone. And only one step, with only one step drillings, we can finish drilling. Trephine 2535. This means 3.5 millimeter in diameter. Easy to make. And then I fed the bone density. I made a 3.5 millimeter diameter osteotomy sockets, but the bone density was not good enough, as you think, because of location. Especially posterior usually has type 4, or between type 3 to type 4. So I tried to use the wider diameter of implants. So I chose 5 millimeter and ridge. Can I place a 5 millimeter diameter of implants through 3 millimeter osteotomy socket? 3 millimeter gingival entrance? Yes, of course, we can place these big implants through this small hole because of the design. You might worry about the gingival damage during placement, but just the fixture can damage only this part, only the small area, and then the other thread just follow the initial thread. So after placement, you can connect the healing abutments immediately after surgery, and then just wait 3 months or 2.5, 10 weeks later, and to give pressure to make a temporary crown and finish the restoration of this. In the other case, similar case, so usually I do surgery like this. So whenever I have this wide ridge, you don't need to have a CT machine. CT machine is very helpful to decide how to recognize how wide ridge the patient has. But you can see with your eye. So, then just make punch 3 millimeter in diameter. And then if you want to use regular drilling, of course you can use. And you can feel different bone densities. And we can use different diameter of implants through the same osteotomy sockets. This area, usually the area near the natural tooth has a better bone density. So I decided to use 4.0 here, 4.5 here, 5.0 here. I made the same osteotomy socket and can determine the different diameter of implants. As you see at the previous case, I can place a 5 millimeter wide diameter implants through this small hole easily. And through the hole, through the gingival hole, you can see the same table because it has the same connections. Even 8 millimeter and ridge has the same connections. Healing abutments, and the other, the opposite side, single crown, single tooth missing. So I need to trephine again. And punch the trephine, the sequence, and healing abutments. It takes only 4 minutes. 4-minute operations without any complications, no pain, much less pain. So sometimes patients can argue, how much you charge this much money on this simple surgery? So as you can say, it's because of my techniques. So I'm very wonderful implantologist, so you should you should pay. Do you want to have pain after implant surgery with severe incision, flap openings? It's because of my technique. You can say. I usually say like that. And then this is after surgery. Let's compare. Look at the bone condition here. So this area looks much denser than this area. So this is very logical to place different diameters. Through even you made the same diameter of osteotomy sites. And 6 weeks later, 3 months later, I took impression. See how much bone it has. So comparing with this implant has much more bone context. Actually, the actual bone content will be almost similar with this because it has a dense bone, because it has, this area has a loose bone. Provisional restoration, and took impression again to finish the restoration. It's very easy to do. So I made a gold crown, cementation time. It's good, it's bad, but not damage on the implant. So, then let's go to the maintenance page. As I told you, for the maintenance, the implant connection and transgingival tissue is very important. So, this area is very, very important for the maintenance after finishing final restoration. Yes, unlike the natural tooth, implant doesn't have any periodontal ligament and any cementing. These two organs is very, very important, as you know. So because of no cementum on the implant surface, we cannot maintain the gingiva attached to the implant surface. So that's the start of a tragedy. So we need to look at these important articles. Very, very important. So Dr. Nozawa and his group observed that the tissue changed for 10 years. And they recognized when the height and the thickness made a disproportion, the gingival margin around the implant became stable. It's very opposite to the natural tooth. Usually, on the natural tooth, the vertical height is higher than the thickness. But on the implant, it became vice versa. We should know about this. Even when we use some surgical techniques to make very aesthetic gingival lines at the beginning, it cannot be stable in that position. Just with time, it will go down and down until it has proportions of 1 to 1.5, as Ozawa group mentioned. This is just a physiology. We cannot change this. If you want to maintain the height of gingiva, you should make the gingiva as thick as possible. Or you should make the bone thickness as much as possible. So this is a long-term observation of gingival tissue change. And we have one more important article. This article was made by Uli Glunder, the very famous Swedish, not Swedish, Swiss dentist. He is a really nice surgeons to make a bone with the GBR techniques. And on his article, he made a very thick labial bone even on the maxillary anterior. This is not easy, actually. Even as I'm very familiar with the GBR technique, but to me, it's not practical. It's very difficult and it takes a long time. But anyway, if we can make this kind of bone that is 2 to 4 millimeter remaining bone around the neck of the implants, he said there's no recession, gingival recession at all. Even he used very bad implant system with the external hex. That means implant itself doesn't affect the tissue response. So we should understand the physiology of the bone and soft tissue around the implants. At least we should have one thick tissue, bone or gingiva. At least we should have one. Or if we can have both of them, it will be much better. So we should just look at this area and this area. Yes. Frequently we have conditions, bone conditions like this. As on these situations, we can use only this amount of bone to leave adequate amount of labial and buccal bone. But for the strength of the implants to withstand the occlusal force, we try to place this wide implants, right? But if we place this wide implants, we have only limited amount of buccal and lingual bone. It can reduce the vertical height. It can make a bone loss around the implants. But Enrich made some magic. So during placement, as you saw in the previous cases, so during placement it looks wide like this, but after placement it disappeared to leave only the platform. So we saw this case already. So during placement of 8 mm diameter fixtures, it looks like this. Only very limited amount of bone, called lingually, but after placement you have enough bone there. So look at this case. This is the first molar, mandibular first molar case. So I placed 5 mm diameter, but with the resorption of the ridge, almost all around the implants, we have bone defects, right? We're going to have bone defects. But after placement, this much. This is not good enough. So we have only 1 mm here, bone here. But compared with this is much more predictable. And I didn't put any bone graft and connected healing abutments to the one-stage surgery. And on the X-ray after 6 weeks, so look at this. It's very nice tissue responses. Right? If we place this conventional 5 mm diameter implants, so we'll make bone dehiscence defects here. You should do bone graft and membrane, and you should make primary closure to wait 6 months at least. So it's too much. So you can simplify the procedures much more. That's it. Yes. The principal concept is similar with the wine opener. Wine opener is very wide in shape, but actually it was made with a thinner strand of wire. Right? But it's strong enough to take off the cork. It's the same concept. So on the Enrich, we put the double offsets for better tissue peri-implant biotype. The first one is a smaller platform, then thread to leave more bone around the implants, and the physiologic anatomy cuff designs for thicker mucosa. So look at this. This is a conventional thread design implant. This is Enrich, same with the same diameter. So we have more bone here. We have more tissue here. This implant has nothing, just the emergency profile. And this concept was issued by the 3i implant systems in 1995 by Dr. Rajara. But at the time, it was perfect concept. We was fashion on this concept. We tried to make a really nice emergency profile with the big healing abutments, but it was long, unfortunately. So look at this. And this is a visual distal view of the implant on the X-ray. X-ray is on the X-ray we can see only medial and distal side, not buccal and lingual side. So if you see buccal and lingual side, it can be different. So, like this, same rigid size, same diameter implants with their abutments. As you see, at least you can make 1 millimeter thick gingiva. 1 millimeter thick gingiva is very important, as you see at the Nozawa's article. Compared with this, and how about the bone? We have a certain amount of bone here, at least always, but here is nothing. And this thing, cortical bone, is ready to be reserved, so very easily. And biologically, as biological point of view, as I mentioned before, so we need to have a stable soft tissue dimensions, at least 3 millimeter, according to the Nozawa group, and 2 millimeter, according to the Salaman group. So we should have a 2 millimeter. Yeah, usually we leave 2 millimeter, but if you use any ridge, you can have a 1 millimeter more soft tissue. And bone is same. So Grunder said we need 2 to 4 millimeter to make a stable crystal bone level, and Spray said 2 millimeter to make a no bone loss. Yes, as you see on the diagram, we can have at least a 0.5 millimeter more bone within ridge. So many people say the end ridge looks like ankylose. Ankylose is very wonderful implant system, as you know. But this diagram was made by ankylose. I like this diagram very much because it is really ideal. It shows the really ideal soft tissue response, soft and hard tissue response. But I have some doubt. So on this diagram, as you see, we should make an osteotomy socket like this, to this level. And then bone will grow to the top to cover the flat bone, according to their insist. But to make this kind of a bone response, we should place the top of the implants quite deeply. If we place the table to here, it will never make this kind of bone growth all the time. So we should place quite deep, more than 2 millimeter, sometimes 3 millimeter below the bone. So it's not good. It's too much. And why we don't utilize this area of bone? I want to use this one. This is also very valuable bone. Why don't we use this area? And I try to make a smaller osteotomy socket than this one to place the same diameter of implants. Smaller hole, but it's unnecessary. I try to utilize this area bone by making thread here. And then, again, I don't want to place implants so much deeply. Just 0.5 to 1 millimeter deep position is good enough to show, to make a really ideal tissue response, a crystal bone response. So this much is good enough. So that's and reach. So it will be different. Looks similar, but different. So this is this diagram was made by ankylose again. It looks very wonderful. And reach looks like this. So if you overlap two images, it looks like this. See, look at this. The only weak point of the ankylose is connection. It's too narrow. There's much more occurrence of abutment fracture here, especially when you use the posterior area. So we enlarge the abutment connection more to give more strength. And look at this. The core diameter is narrower than the ankylose, but we engaged we grab more bone underneath the crestal edge, crestal bone crest. So, similar concept, but more stronger. The surface area is very interesting also. So by enlarging, by making the deeper thread, the surface area of any ridge increased around 45%, 48% compared with the each plus. It's a lot. And insertion torque. Insertion torque means initial stability. Insertion torque increased almost 40% again. And I made some interesting game. I calculated the surface area from the top to each thread. To the thread, fourth, fifth. So we have some computer program to calculate all the surface areas. And then I made this note. Okay? And I compared with the surface area of each plus. And this is the most popular system we are using now in the world. And we have some confidence with 4 by 7 millimeter each plus. We can use this on the mandibular posterior, on the mandible, because of density. It has only 130 square millimeter of surface area. That means if we can use this much implant area to be placed into the bone, so we can have the same surface area with this. Or if you don't like the 4.0, okay, 4 by 10. 4 by 10 is most popular implant size we are using. The 4 by 10 has 164 square millimeter, and then only one thread deeper. If you place this one, only 5 threads engaged into the bone, so you will have almost same surface area with 4 by 10. That's enough to be integrated, to have the strength. So, I decided our group. Some of my friends decided to challenge a new world record. As I mentioned, we have 5 millimeter shoulder implants. It's good enough for the maxillary posterior area when patient has a wide enough reach. But we challenged the new world record on this case. Actually, we are doing the prospective studies on the cases like this. So look at this. The patient was a 74 years old lady. As you see, the period condition was not good. And then we remove the tissue. Of course, we have some bone graft here. But how about this? It has patient has only 3 to 4 millimeter bone under the crest. Can you do sinus bone graft? Yes, easy. But if you can do implant without sinus bone graft in this case, how wonderful it is. Patient is 74 years old. She doesn't have enough money to pay sinus bone graft. So I recommended the shoulder implants. Actually, patient don't know anything, right? Just try to place 5 by 7 millimeter long, because we don't have 4 millimeter shoulder implants. So just place the 5 by 7 and reach, but only this part, half of these implants engaged into the bone, 3 to 4 millimeter. So on the X-ray, this is after surgery. It's because of initial stability, as I connected healing abutments immediately. Healing abutment is longer than implant itself. And then, see, 3 months later, I took impression. Only 3 months later, can you take impressions? Yes, because 4 by 10 millimeter surface area was engaged with a healthy bone. So why not to take impressions after 3 months. And I delivered the temporary at 4 months and 5 months, finished all the case and the follow. Not for a long term, but patients feel very happy. And we did several cases, more than 10 cases now. Every case is one, except one. I can show one more case. Let's look at this. So, yes, more bone is growing. It's making on the sinus side. I can show one more case. This guy is very young, only 23 years old, and he's studying in the United States. And he wants to finish. He wants to do something on this area because he has congenital missing. It's like this. This deciduous tooth, primary tooth was lost, and the height was only 3 millimeter, exactly 3 millimeter, and the width was only 5 millimeter. So what kind of implant system you want to use? So we'd like to use, usually we use 5 millimeter wide diameter implants, but not enough. We need to make a bone here, we need to make a bone inside the sinus, but he didn't have enough time. So she had to go to the United States to study. So this is my friend's son, actually. So I recommended to place in which through the small hole, I placed the 5 millimeter wide diameter implants. So during placement, yes, exactly. This is 5 millimeter. So you can see the width of the ridge. Exactly 5 millimeter. And then when I placed, it went down. Only 3.3 millimeter core was exposed. And I had this much bone concomitantly and connected healing abutments. At the surgery, it looks like this. See? So let's compare with the diagram. So how many threads are? Threads I engaged with the sound bone. So 1, 2, 3, 4. So from the top, I engage this much implant surface to the bone. See? And then this is almost same with this. By 10. After finishing the final restoration, the case, I saw the X-rays, and I surprised a little bit. So when I placed implant, I just had a 4 millimeter, 4 thread into the bone, But after finishing, above this 4 thread of bone, I had 3 more. That means I had more bone here. It's because of implant surface. Implant surface is very bone attractive, osteoconducting. So usually you will find more bone growth about the sinus floor. Connection is very important. Bone destruction starts from this gap. But this connection will be explained by Mr. Her at the mean. We had many tests on the degree of connections between abutments and the fixtures. So we found 5 was nice. Ankylose is 5.8. And the others has many different kind of connection angles. But on our experiment, 5 was wonderful. So Mr. Her will explain this later one by one. I'll try to skip this. And one more very important thing left. As I mentioned, I like microstructure much more. But as you know, microstructure is important to fasten the integration period, to minimize the integration period. That is surface treatments. We are using Super IBM surface treatment techniques. Super IBM means modified IBM techniques to make a better surface. It looks very similar with SLA. And now our Super IBM is very similar. with the SLA on the SEM image, but we decided to change our implant surface based on SLA surface. So we named it as X-Speed. Excellent speed means X-Speed. Usually, SLA surface was made like this: plastic with large grit and acid etching with a strong acid, and washing in the packaging. That's it. Sometimes one of my employees can be lazy to wash the implant surface, and then we can have a big disaster. I know many implant companies in the world made the same mistake because of these acid residues. So we hesitated so far. As for many years, I've been on SLA is better than IBM. But we tried to make the same quality of implant surface with the IBM techniques. So we developed Super IBM techniques. But now we finished to develop new techniques. So after this, we do 2 more steps: alkalinization and the calcium ion incorporation procedure. So after this, we do alkalinization and the calcium incorporations, and we modified the conditions. We changed the size of the particles, plastic particles, and time, temperature also. And after this, because of the alkalinization process, we can never have acid residues on the surface, because it means very safe. So on the SEM image, so if you compare with conventional SLA treatments, XP SLA surface looks very similar, right? But on statistics, if you calculate the roughness with the special equipment, you can see the difference. So we always think RA is very important. RA means arithmetic average of absolute height value of all point of a profile. That means just average. Average seems almost same. But we should know about the importance of maximum RT. RT is maximum peak to valley height of the entire measurement. So, if this is high, RT value is high, it means it's very irregular. Some area is very high, some area is low, even the average is same. But with the advanced techniques, so we made very even, very stable RT values compared with this, almost 50% stable. And we added the calcium ions on the surface. Calcium ion will be released from the implant surface during the integration procedure, and it can stimulate the osteoblast to make a strong and faster integration process. And when I talk about these techniques and these surface treatments, so everybody asks me, what's the difference between HA technique and your XP techniques? It's not HA techniques. We only quote HA calcium ions only, not phosphate. We don't need phosphate because there are a lot of phosphate ions in the body, so we don't need to add phosphate. And with this technique, we can minimize the thickness. As compared with the other HA techniques, you can see the thickness is almost 10 micron. But this ion coating is only half micron. It's 500 nanometers. It's a nano coating. So this is the current surface treatments IBM. SLA surface looks similar. the roughness RA value is almost same. Yes, but it's a bit sharper because of acid. So, but if you do XP treatment with the calcium ion, this small roughness was made by calcium ions. So it's ready to be released. So on surface, so BIC was increased this much by changing the surface techniques. So this is a very simple case to show you the trial of X-speed. So after the X-speed treatment, the implant surface will change to glue. It's a glue implant. So this is one of the first cases with X-speed treatment. This was started in 2008. It passed already at least 3 years. So we tested because the surface change is very, very critical. And with a very nice result, very stable result, as you see, to almost 3 years later, as you see, very stable, no adverse effect. We didn't test. We are testing now how faster the integration occurs. But the safety side has nothing to lose, nothing bad. So similar cases, all X-speed surface is plus was placed and showed very stable response, as you see here. So X-speed is safer and faster and stronger so far. At 3 years experiment and clinical test. And we will apply these surface techniques this year, at the end of this year. But just the macrostructure will give you better result with the enrich. The design was made not by me, from the ideas of our users, our customers in Korea. So with enrich, and with the X-speed service, it will be changed to blue. So just wait for a few minutes, a few months, so to have a blue enrich. As you can, I'd like to welcome you to Jeju Island. So at the end of this year, it's November 11, 1111. So we'll have a very nice symposium. You can enjoy the wideness and beautiful scenery of Jeju Island. Thank you very much. Thank you. Do you have any questions? Oh, as you see, my email is Perio. I'm a periodontist. Perio, PKB is my initial. And Hanmail or Gmail. You can use Gmail also. And whenever you have some question, any kind of. So I usually have a lot of cases every week. I answer one by one. I try to share our ideas of implants and some clinical cases also. Any question, welcome. Thank you very much. Thank you. Please.
May I know your glue sequence for the 5mm diameter implant? And is there any danger of perforating the buccal plate when you place that 5mm diameter implant in the narrow reach of 5
millimeter? Yes. It's very important and good questions. Asked me, Dr. asked me, so what's the dual sequence for the 5mm enrich? Or did you have any accident of broken cortical bones during placement? Yes, the first question, the answer is, it's up to you. It's very ridiculous answer, right? But we changed the dual sequence, totally different from other conventional implant systems. As a doctor, we have to think, we have to decide what kind of bone patient has. So according to them, so we can modify. 5 millimeter is not mandatory. Usually, we are used to use 5 millimeter diameter implants on the posterior mandible, posterior teeth because of trends. But anyway, 4 millimeter diameter implants has the same strength with the 5 millimeter, actually. So on the mandible, you don't need to use 5 millimeter. Just try 4 millimeter is enough. With my 4 years experience. But if you want to use 4 millimeter, 5 millimeter diameter implants, okay. Yes, according to the bone density, on the maxillary arch, you can start to place implants after 2.9 millimeter. 2.9 is very small, only 2-step drill, 2 millimeter and 2.9, and the 5 millimeter diameter implants can be placed when patient has type 4, very loose bone. On the mandible, to place 5 millimeter implants into the hard bone, like a D1 or D2, very hard bone, you have to drill almost same diameter of the implant. So you have to drill to at least 4.8, or sometimes more than. Sometimes you have to use crystal bone drill again. 4.2 to place 5.0 5 millimeter diameter implants, you have to drill almost same diameters. You have to use almost same diameter of drill. So, on the hard bone, same diameter. Soft bone, you can decide. You can start from minimum. So if you use rigid split techniques, it's only 2 millimeter, isn't it? 2 millimeter, and you can start to place wide diameter implants. So it's up to you. Very ridiculous, but to me, as a dentist, we should decide. That's the sequence. That's the basic concept of language. It looks a little bit vague. If I used to use different kind of implants, try on the maxillary first, on the soft bone, and then try to the hard bone. I had one case, as you mentioned, the broken cortical bone. And one more case, I had a perforation and pressure necrosis on the. I used at the beginning. I tried intentionally. I tried maximum torque. Most of the case was good, but one case had a broken cortical bone. So in that case, there's no problem because I used the GBL technique again. But one case, suddenly the patient showed fistula in the buccal area. And I opened the blood. The crystal bone was sound, but there was undercut, but the deep thread engaged the cortical bone too much. So it was necrotized. So there was one case. It was on the maxillary, undercut. But not that much complications is worried. That thing, no need to use 5 millimeter diameter implants on the mandible. We had a lot of complications, like implant fractures and something like this. But this is much more stronger than the average 5 millimeter. Compared with Easy Plus, our common implant system, internal system, NRH is 50% more stronger than the Easy Plus. The technique was designed like that. So, thank you for your question. And because of time limit, I'd like to pass the mic to Mr. Jun to continue, and later, so we can have a question.
So it's time to have a coffee break, just shortly 10 minutes. So after 10 minutes, I want to present my product, the introduction. So please have a cup of coffee for 10 minutes. So we will be back again 10 minutes later.
送翻出嚟，即係買嘢，成個骨攞埋出嚟。 就子宮可以擺個心理嗰個7、8，即係你睇緊係幾深咁咯。唔係，即係我識嘅佢就係呢就可以放時間嘅先嘅，即係邊埋嚟睇，邊個係關好多錢，兩個咁咪有時仲有啲邊個佢唔知啊，就冇話邊個，即係邊個唔知。
afternoon, everyone. Well, as I introduced myself at the first time of this seminar today, my name is Jun Heo. I'm a educational manager as well as a product instructor of the magazine implant. Actually, I graduated as a dental technician when I was in the colleges, and my knowledge basis come from the dental technician. That's why I'm going to talk about the prosthetic as well as abutment of the annuity. Actually, it's the third time to be in Hong Kong, but the last two times was summer season, so it was absolutely hot. So I was so tired and very difficult to stay in Hong Kong, but it's the very nice weather nowadays. So I'm very happy to be here with with yours. And today I'm gonna present about the controversial matters in implant prosthetics. Are these inevitable, which means should we face on the some problem regarding the something the prosthetic things. So as where when you have a patient, you should do the diagnosis, and then as Dr. Park focus on the surgical part of the enlarge. The surgical part is very, very important to prevent any problem about implant treatment. And also after that there will be some osseointegration period, and then the case by case you can do this. You should do some second surgery, and the prosthetic procedure is important too compared to the surgery. So that's why I'm focusing on the the prosthetic procedure and something controversial matter about the prosthetics today. So if you focus on the surgical point of view, and if you take care of the the prosthetic point of view, you can get good result of the implant treatment like that. So you can get some beautiful prosthetic like that pictures. So what are frequent problem in the implant prosthetics? The most of the things frequent problems make you headache, like patient will complain a lot, and as some doctors asked Dr. Park just before, even they have some screw loosening, they will complain about implant loosening, which it is very difficult to persuade them it is safe or not. The patient will always complain again and again and again. So when we developed the anti-itch product, we focus on to solve that kind of the headache things come from the prosthetics. So there are a lot of frequent problem in the implant prosthetics. As you see here, cementosis, inaccurate margin, veneer fractures, implant fractures, a lot of things, screw fracture or something. But most frequent problem in implant prosthetic is the screw loosening, as as one of the dentists asked to Dr. Park just before. Yes, screw loosening is the most the complicated problem in prosthetic part. So as I told you, when we developed any product, we focus on to remove screw loosening problem with NRH. So, but before I introduce NRH doesn't have any screw loosening, I should introduce where does it come from? Screw loosening, where does it come from? Where according to the many articles, where the screw loosening normally the implant in malposition leads to the screw loosening. Yes, definitely. And micro movement between the picture and the abutment will lead to screw loosening too. And also, something long occlusal schema will lead to the screw loosening. And the type of the implant connection, external and internal. According to the Dr. Levin's articles, external connection. Oh, sorry. So there is a lot of methods which lead to screw loosening, mainly big pole is over there. So, according to the Dr. Levin's articles, the external connection will occur the screw running much better than much more than the internal connection. So we choose, our new product, which is Enrich. We'll choose the internal connection, and the most important thing is micro movement. We want to remove the micro movement between the picture and abutment, so that we can minimize the screw loosening. So we should look for the micro movement between the picture and abutment. Where micro movement, the main reason why there is a micro movement is there is micro gap between the picture and abutment. As you see it here, there is some sliced white line between the picture and abutment, which means there is a micro gap, and also there is a micro movement. And also, the abutment screw and the picture female screw, there is there's no proper contact between the abutment screw and the female screw of the abutment implant. So if there is some micro gap and there's no long contact between the screw and picture, there will be the severe micro movement. So micro movement, same as a micro gap. How can we solve? How can we solve that problem? It's the many dentists insist that the locking taper will solve the micro movement and the micro gap. So we choose locking tapers. Actually, I participated in the Hong Kong Dental Exhibition last year and the year before the last year. So whenever show I enrich to Hong Kong dentists, they always ask me, it's similar to the Bicon or it's similar to the ankylose. Is it same connection as the ankylose or the Bicon? Apart from the Hong Kong dentist, actually I traveled a lot, and when I met some dentists in the world, they always ask me, oh, its connection is very nice, but it looks like a Bicon or it looks like ankylose. Is it same, right? But definitely no, because the Bicon has a strong connection, yes, and ankylose, they also have a strong connection, but their connection, each angulation of the picture, Bicon has 1.5 and the ankylose has 5.7. So our R&D department, when they developed Enrich, they tried every single angulation of the implant connection from the Bicon to the 11 degree, which is Astra's connection. So they tested 0 by 0.1 degree, and then we found the Enrich connection, which is 5 degree, will be the best one according to our test. So and also we tested our connections were compared to the Bicon and Strauman's, which is 8 degrees each angle. So after connecting the abutment into the picture according to the manufacturer's the instructions. So Strauman's, they connect abutment with the screw with 25 newtons, and then Bicons, and there's no screw with the Bicon picture and abutment. So they piloting and they press with the 35 newtons, and then our product Enrich, we connect the abutment with the screw with 25 newtons according to the manufacturer's recommendations. And then after removing the abutment screw, we tested how much newtons we need to take out the abutment from the pictures. So the test result was like this. 16 means the 8 degree plus 8 degree, which is the Strauman's 8 degrees most taper connections. They need the approximately 11 newtons to take out the abutment without screw, and the Bicon with malleting, they need 25 newtons or something, but Enrich needs almost 15 newtons. Even Enrich doesn't use any mallet and any press, and even we give less newtons to connect to connect abutment into the picture, but the connection is much stronger than bicone, which means even the abutment screw unscrewed by some reasons, the abutment and picture connection will be very stable. So there's the less movement and less possibility to pace on the screw loosening. So we choose 5 degrees most taper and internal hex. So when you connect the abutment into the pictures, there is the SEM pictures like that. There is the tight connection, tight contact with the abutment screw and fixtures, and there is no micro gap between the fixture and abutment, which means it will be solve the screw loosening compared to the others. So unique deep pipe internal tapers, more abutment to picture surface area for the better distribution of the force stress with the conical seat and no screw loosening, and the deep internal hex will give you the great feeling to connect abutment into the pictures. So I tried with my colleague in the Korea in our office. As you see her, she gonna connect abutment, rear energy abutment and the fixtures with just the finger force, which is less than 5 newtons. And she connect screw in, and then she gonna take out the abutment. She gonna take out the abutment screw, and then there's no screw on it. And she tried to take out the abutment, but she can't. So we hired some the man of his pet. So he tried to take out the abutment, but she couldn't as well. So we invited the most fattest guy in our company. But the problem of him is his hand is too big, so he didn't grab the abutment and fix it. Anyway, even his the big power, he cannot take it out. So you can try out there back there. So we have some sample picture and abutment. So which means I'm pretty sure we have a strong connection in the world compared to the other implant systems. But sometimes some dentists, how can we remove the abutment? If we cannot remove the abutment, it will be very difficult. So normally, of course, we have some special tool to remove the abutment. So the secret to remove our abutment from the picture is the internal female screw in the abutment. So just you can rotate it the clockwise direction with the abutment remover driver. You can easily take it out. And also the other question was for the temporary things like temporary cylinders or impression coping or healing abutment, if they have a strong connection, it will be very difficult to connect and reconnect or something. So for the transitional and temporary component have a ridge like that here. So it will not have any strong connection. So you can easily move with just a hex driver. But all the component, all the permanent abutment like gold abutment or the two-piece abutment, solid abutment, or the ball abutment, or something like permanent abutment will make a strong connections to prevent screw loosening or any other problem. And other considerable factor in implant abutment, where to develop the ideal abutment, we consider these things like this. easy to use, strong connection, strength gingival curve, and aesthetics, and taper of the post or something like that. Lots of things we consider to develop our abutment. So you can see, the consideration and design concept for the enriched abutment, which we call the ideal abutment. So as you see, the crown was much bigger than the picture, and to prevent, screw loosening problem, we choose internal deep hex with conical seal, as I explained just before, and biological S-line, which means, normally the crown is much bigger than the root for the point of the natural teeth. So, the connection part between the crown and the root is not a straight shape. It should be, curved shape. So we revealed that kind of the, the natural anatomy, and various transgingival curve heights from 2 millimeters to 5 millimeters. And 2 different post heights, and the taper of the various, taper of the post various, which is the molar. The abutment for the molar will have a much taper than the anterior, and the 1 millimeter brief over shoulders. And according to we have a lot of the strong connection, so we can minimize the screw head, which means we have more thickness to the milled abutment compared to the others. And the other advantage using the enrich is enrich has the pixel diameter from 3.5 to 8 diameter, which is mixed with each plus like less cube. So we have the various healing abutment, so that we can cover the small things and also big extraction socket. And also there's various cup heights of the healing abutment. And normally where the dentist, they want to have all the option for their the possible treatment of the implant treatment. So we provide all the option of the prosthetic. That things is just conventional options like a UCLA gold abutment, 2-piece abutment, and solid abutment, which is 1 piece, and angle abutment with enrich. And this is the mostly the dentist used 2-piece abutment we call easy post. It also has the natural shape, which is if we make a natural shape like that, you can get more gingival and more stables, and also 1 millimeter 1 millimeter consistent contour, which means there will be some the situation which the gingiva, the height of the gingiva will be different between the buccal and lingual area or mesiodigital area, so that you can the customized milled that 1 millimeter consistent contour. And it has the various cup height and also 2 kind of the post heights, so you can choose according to the patient situations. And also angled abutment, as I told you, enrich has a hex connection, which is 6 directions you can get for the angled abutment with angled abutment. But we have 2 kind of the angled abutment apart from the the angulation. Each angulation, which is 15 degree and 25 degree, both of them has 2 types of connection. Oh, sorry. Yes, here. Oh, sorry. So here, this area and this area are different for each angled abutment, which means internal hex connection will give 6 direction of the angled abutment, but we changed here and here. 2 types of the angled abutment exist, so you can get 12 direction of the positions, which means it will be much better than to choose the angled abutment. And also we have a solid abutment, and most of the components are very similar to the conventional implant to prevent your complication of using the solid abutment. And solid abutment has 3 options of the post height and various of the cup height, so you can easily choose according to the patient situations. And also, we provide temporary abutment, which is machined things, as well as POM material, which is very good at to attach, the resin temporary things. So there is some clinical cases. There is a broken between the root and the crown. So take it out the broken crown, and there is a root rest cases. So of course we should take it out the remaining root and placing the enrich. And then by taking out the natural teeth, we can make a temporary crown with our POM temporary abutment. Just there is some milling here and make a temporary crown into the here and attach it with the just normal milky resin or some things. So we can easily make, and while we make a final restoration, the patient can get the temporary crown with the natural teeth. If so, for the aesthetic point of view, there's no problem. Of course, the dental technician should make like a natural teeth for the final restoration. So probably dental technician doesn't like to do these kind of things. So that is the final restoration of these clinical cases. And also, with using the POM abutment, there is some special technique by Dr. Thomason in UCLA University. He placed 4 temporary plastic abutment into the maxilla incisor area and some bone grafting. And to cover the extraction socket, he used the gingiva from the palatal and grafting like this. And then you can make a temporary crown and like this. If so, you can get the much gingiva when you make final restorations. And also we provide the multiple abutment, like multi-unit abutment. We provide octa abutment and ball abutment for the overdentures, and kerato ball abutment and kerato abutment for overdenture too, which is absolutely similar to the locators. So there's no difference between the locator and kerato. Just you can use kerato abutment as a locator abutment. So because of the time limitations, I prepared a lot of things, but I cannot introduce all the things, So whenever we have a seminar in Hong Kong, I will be here. So if you have any questions, if there is Dr. Park is not here, so you can ask me. And also if I don't have your question, the answer of your question, I'm very close to Dr. Park, so I can ask Dr. Park and give you answer instead of him. So this is a summary of the NAH, which is today's topics. You can see. Well, the meaning of the dead cube is we have a lot of product, and the manufacturing a lot of product, we have knowledge what gonna be either implant fixtures. So well, the first advantage of the NAH will be we can preserve cortical bone area, which means we can get more stable bone condition and also more stable gingival conditions. And also our the thread design will give you the good initial stability and early loading. So our the advanced thread design will give less stress, but more good initial stability, and also the connect also the platform area. We can place the wider implant even there is the limitation reach. So compared to the other company, we have a narrow platform, so it will be very helpful. And also we have a strong internal hex connection, and also from 3.5 diameter to 8 diameter, we can use the same implant, which is a very good advantage. And as Dr. Park introduced you, double offset or something like that. So we have the natural curve of the curve design and 1 millimeter consistent contour. So you can build whatever you want like that. 1 millimeter consistent contour. So you can just build. Also, to prevent screw loosening problems, we choose the strong connection, which is 5 degree. So there is absolutely great strong connection between the abutment and fixture. So there will be no screw loosening, but just 0.1% can be occur screw loosening. So using the energy, you can get the nice clinical result like that. So, also you can ask me about the point of the prosthetic questions. You can ask me, and I'm gonna give you answer. Actually, I also have a lot of questions from all over the world. So you can directly contact me, or you can ask Jesse Young. He call me 5 times a day if he has questions. Whenever I got his calling, I try to do my best to give him the answer. So please do not hesitate to ask him. And the Megadin implant, we're gonna organize the more seminar for the high advanced technique as well as the lot of things to help your clinical technique as well as your practicing. So whenever we organizing the seminar, please feel free to visit our our seminar. So thank you very much for attending today, and hope to see you again. Thank you very much.